This video is for the solving equations from quadratic functions notes. A picture frame for an 11-inch by 14-inch rectangular picture has a width of W inches. The total area of the frame in picture can be represented by the function A of W equals 11 plus 2W times 14 plus 2W, where W represents the width of the frame on each of the four sides. So number one, identify the independent and dependent variables represented in the question and the function. So the independent variable is the W, which is the width. The width of the frame. So the dependent variable, which is A of W, represents the total area. And that's the total area of the frame and of the picture. So we're going to write a simplified version of this function. So to do that, 11 plus 2W times 14 plus 2W. So 11 times 14 is 154. 11 times 2W is 22W. 2W times 14 is 28W. And then 2W times 2W is 4W squared. So we can combine like terms, put things in order. So we would put 4W squared first. 22 plus 28 would give us 50W. And then the constant at the end. All right, number 3, determine the solution to the question tabularly, graphically, and symbolically. So we're going to use the function to create a graph for our function here to determine the width of a frame with a total area of 250 square inches. So what we're going to do is we're going to graph this. The easiest way to graph a function like this is to get some points you can use. So I'm going to go into graph here and I'm going to type my function. Now I'm going to use an X on the graphing calculator. And then I'm going to pull up the table. And so now I've got some points that I can kind of graph here. So when, let's see, where do I want to start? If we look at our graph, we're starting at negative 14. So let's kind of go there. So at negative 14, X is negative 14. Y is going to be about 238. So it's, let's see, 200. It's going to be about there. It's going to be a little bit below it. Okay, and we can keep graphing this way. I'm going to skip to negative 12 is about 130. 10 is 54. See, negative 8 is 10, so that would be pretty low. And then I'm going to look at the graph, Control T, and find the vertex. Oop. Try that again. So menu 6, it's a minimum. And then I kind of get my vertex is at negative 6.25 and negative 2.25, which is pretty close to 0 on this thing. It'd be somewhere in there. And then I'm bring my table back up and kind of start graphing the rest of these points here. So negative 6, let's see. Negative 6 would be a negative 2, which is going to be really low. Negative 4 and 18. Negative 2 and 70. Let's see, 0 and 154. We'll do one more, 2 and 270. It at least gives me kind of an idea of kind of what this is going to look like. So quadratic, I know my vertex is a little bit off here. I'm going to go ahead and kind of try to graph what this should look like. And so what I can do, if the total area is 250, I can kind of line this up here and draw a line where the graph crosses 250. And then what I can do, where these intersect, here and here, I can kind of make an estimate. So what I would do is I would follow that point down to the x-axis, both points, and where they touch the x-axis. So this is a little bit more than -14. This one's a little bit less than +2, in between 1 and 2. So we can't have a width that's a negative number. So this has to be the solution we need. So I would say that if the area is 250, the width would be about 1.75 inches. So anywhere between 1 and 2. It's pretty close to 2. All right, so with the table, we can still use what we typed into our calculator. And I can fill out this table. So when x is 2, there it is, a of w is 270. When w is 3, a of w is 340. When w is 4, a of w is 418. When w is 5, we get 504 and 6 and 598. So for this one, we're looking if a frame has 460 inches. So in between 4 and 5 is where my answer is. Now that's a pretty wide gap though, because we're looking for 460. So between 418 and 504, that's a pretty big gap. So what you can do, the function value of 460 occurs between 4 and 5 inches. We can change the interval of the input column to 0.1 to better approximate the solution. So what I can do with this table, I can do menu, and then table, and then I can edit the table settings. So see where it says table step is 1? I'm going to change that to 0.1. Now you could also plug and chug with this. You could plug in the values of 4.1, 4.2, and work them by hand. So 4.1 is 426.24. Ooh, I got really different values. Okay, so 4.2 is 434.56. 4.3 is 442.96. 4.4, 451.44, and then 4.5 is 460. So this one works out nice and pretty. They don't always do that, but again, it kind of narrows it down, and you can be a little bit more accurate with your solution. All right, if the area of the frame is 340 square inches, what would be the width? What would the width be? Solve the related equation. So I can plug a 340 into my original function, and I can solve this. And so what I need to do first is I need to get everything on the same side. I'm going to switch pins here so I can write a little bit smaller. So this side would equal 0. 4w squared plus 50w. 154 minus 340 gives me negative 186. So I've got an A value of 4, a B value of 50, and a C value of negative 186. I can plug this into the quadratic formula. So negative B plus or minus the square root of B squared minus 4 times A times C divided by 2A. And so 2 ways to solve quadratics. Some people like to do the square root and knock that out first. I like to just type the whole thing in and change the plus or minus sign. So we've got negative 50 plus, then we're going to do the square root, 50 squared minus 4 times 4 times negative 186 over 2 times 4, and then come back up here and change this plus sign to subtraction. Let's do Control Enter. Okay, so our first answer was 3, so we got W equals 3 and W equals negative 15.5. So the width must be positive, so 3 inches is the only reasonable width.